If you've ever walked past a skyscraper going up, you know the drill. Plumes of concrete dust, diesel generators rumbling, and heavy machinery idling. All that localized chaos adds up. Roughly 60% of a building's lifetime greenhouse gas emissions are generated right here, during the construction phase, along with massive spikes in particulate matter. The industry's solution to this localized pollution is modular construction. Instead of mixing and pouring on an open city street, the heavy lifting moves indoors to a controlled factory floor. Workers prefabricate entire sections of the building, fully framed rooms, then truck them to the final site and simply stack them together. This chart shows exactly why developers love the method. It cuts construction time by 40%, reduces waste by 70%, and drops on-site dust by 60%. At the site level, shifting the work to the factory floor appears to be the definitive technological fix for the industry's pollution problem. To see this on a macro scale, we can look at two of the densest skylines in the world, Hong Kong and Singapore. Recognizing the site-level benefits, both cities rolled out aggressive policies in the early 2000s, offering incentives to developers who adopted modular techniques. The logic is straightforward. If the technology drastically cuts dust and emissions at the site level, 2 decades of modular policies should give both cities noticeably cleaner air today. But the actual air quality measurements from the last 20 years show a reality that doesn't match that logic. Fixing the individual building didn't clean the city. Researchers Riki Zhang and Yishuang Xu tested this assumption. They used a difference in difference model, a statistical method that compares groups over time against a control, to isolate the exact environmental impact of these modular construction policies. They tracked the regional concentrations of 5 specific emissions before and after the policies went into effect: greenhouse gases, nitrogen dioxide, ozone, particulate matter, and sulfur dioxide. The results were surprising. In several models, the modular policies actually had a positive effect on greenhouse gases, meaning emissions went up. The spike makes sense when you look at the logistics. Moving thousands of tons of precast concrete modules from a factory in mainland China to a site in Hong Kong requires a massive amount of heavy transport. This chart shows nitrogen dioxide concentrations from 2000 to 2004. The policies failed to cause a regional drop across both cities. Instead, Hong Kong's data climbed rapidly after policy implementation in 2002, reaching 59 micrograms per cubic meter. The regional macro data contradicts the site-level promises. Simply updating the building codes did not instantly save the local environment. So, if the technology is proven to reduce dust and emissions on site, why did the policy fail to clean the air across the city? The first factor is scale. Offering floor space exemptions to a handful of private developers doesn't force widespread adoption across a metropolis of thousands of buildings. The second is time. Because average construction cycles take up to 3 years, there is a massive delay before any policy effect actually materializes in the regional data. But the largest factor comes down to the heavy hitters. Construction is just one small variable in the massive equation of urban emissions. Massive shipping and freight operations consume incredible amounts of diesel and industrial electricity, drowning out the localized air quality gains made by modular construction sites. Add in the overwhelming exhaust generated by millions of motor vehicles packed into dense city streets, and the environmental winds of a green building are quickly swallowed up. Ultimately, a city's air quality is governed by the sheer output of these industrial sectors. The footprint of a few new residential blocks is too small to move the statistical needle. Modular construction is not a failure. It remains highly effective and absolutely essential for protecting the immediate health of construction workers and local neighborhoods. But this contrast between micro-success and macro-reality provides a crucial lesson for future city planners. Future policies cannot simply encourage green tech on the margins. To actually move the statistical needle, they have to mandate these practices at a massive scale. Solving urban air pollution requires a systems-level approach that tackles the energy grid, the shipping ports, and transportation networks simultaneously. Building a green modular home and plugging it into a dirty urban grid still leaves you with a polluted city. To read the full data breakdown and explore the urban paradox study for yourself, visit sherryshu.com.